Hi, everyone. I'm not sure what I did to deserve having to go after Steven Johnson, but I'll do my best. My name is Jiahao Chen. Some of you may know me as one of the founding members of the Julia Lab in 2013. In 2017, I left academia in part due to the vagaries of money, so I decided to go to a place that had money. But it wasn't this place, it was Capital One, and as of March this year, I have moved on to a bank that has more money, which is JPMorgan. I'm here to tell you today about where I work and the kind of research that a financial institution is interested in working on. So here's the legal disclaimer. This is not investment advice. If you lose money because of my talk, I am not responsible, and neither is my employer. JPMorgan Chase, by the numbers, this is an enormous company. There are, first of all, 253,000 employees of this company worldwide. That is larger than certain countries. The other factoid I think that really highlights the scale here is that JPMorgan processes more than $5 trillion worth of payments every single day. So multiply that by the almost 200 years that the bank has been in. Obviously, it's not been 5 trillion every single year, but that's a lot of volume of transactions. Each of these have to be recorded, each of which is data that a financial institution has to take care of. And so this hopefully gives you an idea for the scale of the data that a large bank like JPMorgan has to deal with. So JPMorgan, like most banks in the US, like every bank in the US, has to be structured according to something called lines of business. There are 4 major lines of business here. So starting from the top left are the large companies, which are serviced by corporate investment bank. There's the small and medium companies, which are served by commercial bank. So we help people, we help companies, issue credit. We give them loans. We help them sell bonds, stocks, IPOs, all of that stuff. So that happens in the left column. And then the right-hand side is what we think of as normal banks. So this is retail, which is like regular people like you and I. If you want a checking account, a credit card, a savings account, that goes through consumer and community banking, which those of you in the US may know as Chase, Chase the bank. And there is also asset and wealth management, where if you're lucky enough to be one of those people that has more money than you know what to deal with, you hire a bank to advise you on how to manage your portfolio, and that's asset and wealth management. And we sit in cross-firm functions as a particular department that helps to think about problems in all 4 corners of the bank to try to understand how it is that AI and machine learning can be used to help make the bank more efficient and modernize and plan for the future. Here are the 3 current leaders of JPMorgan AI Research, which is a cross-firm function that I am part of. Manuela Veloso is the head of JPMorgan AI Research. So some of you may know her as the former chair of machine learning at Carnegie Mellon. She is currently on leave from Carnegie Mellon. And so I think there's little doubt that she brings many decades of expertise in how to do proper machine learning and AI research. And I think it's a really exciting opportunity to work with someone of her caliber in a bank to really understand what it is that this particular discipline can do for a field and industry that traditionally has not been very innovative in this area. So I report directly to Prashant, who is the person on the top right here. So he also is a PhD graduate from Carnegie Mellon. He's worked many years in the banking industry. So it's really interesting to see how the leadership here spans a mix of both business and academic experiences. And then Tucker Balch, who is the other research director, he's on leave from Georgia Tech as a full professor, and he's taught in all sorts of areas. And I think one of the things that he's particularly known for is if you've taken the machine learning for trading course on Coursera, that was a course that was like 200,000 attendees that he taught. I think it was quite well received. So yeah, I'm really excited to be able to work with these people. What do we actually do within JPMorgan AI Research? So by far, our first task is in the top left bit here. We are charged to do publication quality research in AI and machine learning. This is split into 4 main areas. There's learning from experience, so you will hear things like active learning, reinforcement learning, those kinds of things. They sit in that corner. Explainability and interpretability, this is an area that we're really interested in. I'll get to in a minute. Data and cryptography is also an area, so you can imagine we have a lot of data. We want to figure out how to compute on it safely, protecting customer privacy and all of that stuff. And finally, values, ethics, and fairness. Are we doing the right things for our customers? How can we prove that the machine learning models that we build are not learning things that are counter to the interests of our clients? On top of that, we also have external engagements with external faculty. We gave out 33 faculty awards this past year. We have 14 PhD fellows. We've invited distinguished lecturers. So we have Daniela Roos from MIT came to come talk to us. Jan LeCun came to talk to us, and Andrew Moore, Michael Woodridge, Jeanette Wing. These are all very well-known people in the field. The lectures that were given at JPMorgan are actually publicly available on our website, so if you're interested, I do encourage you to go have a listen. We also have internal engagements. We have internal networking groups. We are currently running a Foundations of AI course for everyone inside the firm. And we also sponsor events, including JuliaCon, where you are today. And as of yesterday, I'm happy to share that we have a new RIPS workshop that was accepted on AI in finance. So if you're interested in this area, definitely do check us out in Vancouver this year and come submit a paper, come talk to us. We're very excited about the program that we have. So here's 2 projects that we're working on. One is cataloging the data universe. So I think you might have gotten a sense of how enormous the data sets we have at JPMorgan can get. And now imagine all the talk that people are talking about these days about reproducible calculations. So imagine a bank like JPMorgan trying to reproduce risk calculations that were used for the 2008 financial recession. Right? This is the kinds of problems that the bank is not currently equipped to do, and we have a regulatory need to be able to do. So can we find, first of all, where is all the data for a given application, for a given calculation? Can we trace all the data sets, all the data concepts that are being used? Can we figure out what is the provenance of the data? Where did this data come from? And if your data is 200 years old, that's not a very easy problem sometimes. Who is using the output of my calculation downstream? Can I reproduce them? These are all questions that are part of the data cataloging problem that I'm working on. And also, once we figure that out, can we start asking questions about whether or not a given application or calculation is actually using data from the best available source, as opposed to the source that somebody who was an experienced data analyst told me I should use this mysterious undocumented data set from this location, blah, blah, blah. And you can imagine that there's quite a lot of that going on in a legacy company. So how can AI and machine learning help accelerate the cataloging of this particular problem? I think there's a really interesting ontology learning problem. This is the idea of like trying to automatically discover a taxonomy, a classification of subjects and data concepts from the data. We also have a long tail of rare concepts, so there's also some needs for rare label prediction, and there's recent interest in machine learning on what is called few-shot meta-learning. I think this could be really useful for this. And also to find missing links and data in the data provenance network, there's a link prediction problem that could be really interesting in this area as well. I only have this much time to talk about it. Please come talk to me if you're interested. We're happy to discuss in further detail. Here's another project that I'm working on. So this is an example of how values, ethics, and fairness come into the banking industry. So as many of you know, the key function of banks is to extend credit when you want it. So if you ask for a credit card, we need to decide if you get the credit card or not. So the customer on the left was a happy customer because we gave them credit. The customer on the right is not so happy because we said no. But the problem here is that that's not enough. We actually have a regulatory need to explain to you why we didn't give you credit. So we need a reason, and it has to be one of the approved reasons. So even in this obviously fictitious scenario, I can't just say that you're not a human, therefore you can't have a credit card. It actually has to be something related to the credit decision. So for example, go get a job is an acceptable reason. All right. So we need to explain why credit is not approved. And so if you're building an automated model to decide how to do this, we need to think about some key questions like, how did the model come to the deny decision? And is the model being fair to all the customers who are applying? You can imagine these are actually immense societal questions for which the banking industry is responsible in a very crucial area in the question of who to lend credit to. So one of the concepts here is disparate treatment, which is treating people differently based on prohibited characteristics. This is definitely not allowed. So if I build a model that uses this particular table, this is definitely not illegal. This is not legal, and also this is not a real credit model. This is not how JPMorgan actually decides how you get credit. All right, but there is a catch-22 because we can't use these as features, but we still need to keep track of these labels to demonstrate fairness, because if we don't know what race you are, how can we prove that you're not racially biased? Right? There's also a proxy variable problem where even if I explicitly don't use these labels, some of these other features may encode the prohibited characteristics. So if your last name is Lee, I think I have a pretty good guess as to what race you might be. And similar questions like that, some of these questions are not so subtle. So here's an idea that we're pursuing within the bank. We need to keep track of the labels, but we can't use them for building the credit model. So what if we just encrypt them so that we keep track of them, but the team that is building the credit model can't see them? They can use all the other features for decisioning, but we don't know if the other features are actually subtly or not so subtly encoding the protected features. So what if we now say, we'll add an extra step here where the team that builds the model also has to build a secondary model to predict the projected features. And some of the work that we're working on within the bank is to enable exactly this kind of cryptographically secure machine learning, where you can train the machine learning model to predict a feature that you never are able to see in the clear. This is work that is ongoing with my colleagues Tucker and Antigone, and as well as two very talented PhD interns, Leo and Junsik. So stay tuned. We will be publishing some of these results shortly. And just to close, we are hiring. I have these fancy brochures. Please come take one so that I don't have to bring them home. And also, even though these are master's and PhD only, we also have a full undergraduate program. So if you're interested in undergrad internship opportunities, those are also available in other parts of the bank. Please come talk to me, and thank you very much for having us.